Choose the reagents needed to synthesize Z2-pentene from propyne. So we are starting with propyne, this 3-carbon atom alkyne, and we see that we're ending up with a 5-carbon chain alkene. So we are changing the functional group and we are adding to the carbon chain. So we can see that these carbons here is the new carbons that have been added. Okay. And we see that we have 1 carbon atom and then 2 more. Seeing this unsaturation here, that it's still an alkene, is a hint that these 2 carbon atoms are likely these 2 carbon atoms that used to be the alkyne. So I'm going to number the chain to reflect this. So there's our 3 starting carbon atoms. And so we're going to assume that where we have that unsaturation between 2 and 3, that's where we have unsaturation in the starting material. And that's what allows us to say that these 2 carbon atoms are the new carbon atoms on the chain. And so in order to form a new carbon-carbon bond, you need a carbon that is a nucleophile and a carbon that is an electrophile. So one reaction that we have seen is that you can take a terminal alkyne, like that propyne, and if you treat it with a strong enough base, you can form an anion. So the strong base that is typically used for this is sodium amide. And so sodium is the counter ion, so this is Na+, and the NH2-, that's the conjugate base of ammonia, so that's the really strong base that can deprotonate this alkyne. So it's going to remove that alkyne proton, giving you a carb anion. So in the case of this reaction, R is the remainder of the chain, so that's that 1 methyl group here. And so then you'd want to add on the correct number of carbon atoms. So we need 2 carbon atoms, and we need the carbon to be electrophilic to react with this nucleophilic carbon. So we're going to attach it to something electronegative that is also a good leaving group, like a bromine. And so when we have that good nucleophile, it can do an SN2 reaction on this alkyl halide, and that's going to form the carbon chain that we are looking for. So we have added in this step 2 carbon atoms to the chain. So you need to have the alkyne present in order to do this deprotonation. So we can see that we're adding to the carbon chain and we're also reducing that alkyne. So you cannot reduce the alkyne until you've used it to add to the carbon chain. So the first step would be the reaction with sodium amide, then you're adding to the carbon chain. And then if we want to take our alkyne and we specifically want to reduce it to give us the Z-alkene, then we need to use the poison metal catalyst that will add the 2 hydrogens from the same face of the alkyne and stop the reduction at the alkene stage. So that means we're using hydrogen gas, that's the source of the hydrogens that we're adding, and we're also going to use Lindlar's catalyst. And that will do the reduction to give you the cis-alkene that we're looking for. So it's adding those 2 new hydrogens to the same face. So you can see them here on the same side of that pi bond. So that means that the answer we're looking for here is C.